Thank you, CarolinaCon, for having me. I'm super excited to be here. I'm Cedric Owens, and I'll be talking about practical infrastructure automation. So some tools, techniques you can use at a practical level for red teams. So a little bit of background information on myself. Currently the red team lead at Twilio. I've been on the red team side now for the past 4 years. And prior to that time, I was actually on the blue team side doing threat detection, incident response, et cetera. So even on the red team side, I do enjoy working closely with blue team members and ensuring that we improve each other's trade crafts and improve the security posture of the company going forward. I am a husband and father to a wonderful wife and kids. We're from North Carolina, but we've been here in Austin for the past 3.5 years. Personally, when it comes to side projects, I enjoy macOS post-exploitation and infrastructure automation. So anytime I do have time to work on a side project, it's usually in one of those two buckets. I also enjoy 80s and 90s nostalgia, as you can see here on the photo. Just takes me back to my childhood and reminds me a lot of the things, the culture of the 80s and 90s that I loved growing up. And the last item, which is the most important thing I'll say for this whole talk, which is North Carolina has the best barbecue. I mean, Texas has some awesome brisket, but it's about that North Carolina barbecue. And I know I've probably gotten myself in trouble here. And as soon as my talk's over, I'll probably be escorted out of the state of Texas. But hey, you gotta state the facts. So what I plan to talk about today is a brief look at kind of what red teams deal with in terms of their responsibilities and considerations, things that they have to be prepared for, and then why there are opportunities for automation, what those are, examples of automation, and then some lessons learned that I have experienced in my career doing red team automation. So overview of red teams today. In a nutshell, our plate looks a lot like what you see here. Like it's so much that's piled on. Like examples include program planning, so figuring out how your red team function fits into the larger security team at a company with changing missions, changing objectives, as fast, quick growing companies, et cetera. Planning effective operations. So thinking in advance about what type of red team exercises or ops you're going to run and ensuring that they're as effective as they can be for identifying issues, systemic issues in the organization and getting those fixed, as well as helping up-level your blue team. Research, mainly because the field of security is constantly changing. So making sure that we as a red team are aware of the threat landscape and that we're taking that into account as we plan our operations. Tool development, customization, just because for our environments, right? A lot of times we need custom things or stuff that's on GitHub may not apply or might need some tweaking. So we have to allocate cycles for that. Infrastructure management, just because every exercise, just about every exercise or operation that we run from a red team perspective, we're going to need some form of infrastructure for things like phishing or command and control, et cetera. The ability to actually execute the operations. So understanding your environment well enough to know that what techniques would actually work to allow you to pivot and privilege escalate and meet your mission objectives. Of course, then being able to communicate the things that you're seeing and finding on your operations with executives in a way that resonates with them and states what the risk is to the business and why they should care. And of course, blue team collaboration. So being able to work effectively with blue in order to validate their procedures and tooling and also help up-level it. And this is just a small slice of the pie, right? There's other aspects that I didn't even include on the slide. So again, there's just so much that is on a red team plate for internal corporate red teams today. So time management, in my opinion, is essential if you want to be effective on your red team. And so adding to that, internal corporate red teams are often one of the smaller teams within security, within the larger security organization. And so you look at a large plate, you look at being small in size, and there's always more work to do than you have available cycles, right? There's always some part of your environment or some process that needs to be tested. So there's always more work to do than you have available cycles. So again, In my mind, maximizing time becomes your key in order to make sure you're spending your time effectively. And in my opinion, that's where automation comes in, because you can take some of your tasks that are repetitive and predictable that you know you will need or you'll need in a certain manner. You can take those and automate them so you don't have to do those things manually. And so next, we're going to look at some examples of automation. I picked infrastructure because in my mind, infrastructure is one of those areas or roles or things that you're going to have to take care of on a red team that is relatively predictable. And since it's predictable and it's needed so often, in my mind, it becomes a great candidate for automation. So some of the core needs for infrastructure for red teams include that it be secure, because again, like that's one of the worst things you'll want is that you're running an assessment for your company, you have your infrastructure up and it's insecure, somebody compromises your red team infrastructure, and now you've put your whole company at risk, right? So that would be a terrible outcome. So it's got to be secure. It has to be realistic so that when blue team is basically when they detect your infrastructure and they start their analysis, it needs to look as much as possible like a realistic adversary, so that blue team will be able to invoke their incident response procedures and go down that path. It needs to be scalable so that you can pretty easily grow your infrastructure as you know, depending on your needs for the specific red team operation. And it also needs to be flexible so that once your domain gets burned or other aspects of your infrastructure by blue team, you can make the necessary changes and keep your operation going forward without being down for hours or days, et cetera. And of course, infrastructure is needed for various reasons when it comes to red team exercises. Like you're going to need phishing servers, command and control servers that you're going to use to control hosts you get access to, data exfiltration. So you may have servers that you stage just for that purpose, where you exfiltrate files to, file hosting services or servers, so that as you gain access to files on the environment, you send them there. And of course, redirectors to protect your command and control servers. So when you look at all these aspects, again, I think infrastructure becomes a very good candidate for red team automation. So here's an example from a phishing perspective of a common use case for phishing infrastructure. So to start, usually the phishing server, some type of Linux-based server will be stood up in the cloud. And once that server stood up, usually GoPhish is often used as the phishing software to go on that server. And inside of GoPhish, you'll build your email template, you'll build your target list of who you want the fish to go to. You'll even add a sending template or sending profile where you provide credentials to whatever email account and provider that you want GoPhish to log into in order to send your phishing emails to the targets that you provided. So all that's set up right there in the phishing server in a cloud provider like DigitalOcean or AWS, et cetera. On the phishing server itself, usually the web ports you'll have exposed, usually 80 or 443, so that you can do, or if you care about this during the op, you can allow pixel trackers to use the web ports so that when people open the emails you sent, you can track the whole progression of like viewing the email to clicking a link to compromise, et cetera. So usually the web port is exposed publicly for that reason. And then when it comes to admin access, so port 22 access to the server or admin port access to GoPhish, since GoPhish has its own admin port with a GUI that you can use to log in. Usually those ports, any admin ports, are going to be restricted to red team IP operator space so that they're not publicly exposed, and as a way to protect your phishing server. So this is a high level typically of how phishing is done at a very generic level across different red team ops. Another look here for kind of a similar view, but for redirectors. So typically the way we use redirectors on our red team ops is we'll have our backend command and control server. This is the server that we're using to, once we gain access in an environment, to control those hosts. So it can be anything from Cobalt Strike to Mythic to a myriad of other C2 servers or C2 frameworks. And essentially our backend C2 server, we're protecting it so that remote access into the C2 server via SSH, that's only restricted to Red Team operator IP space. And the access to the ports, whatever services you're using for your payloads, for your C2 payloads. So in this case, let's say if your C2 payloads are using SSL. So in this case, any access to SSL on the backend C2 server is only allowed through a redirector. So what that does is it protects your C2 server so that the web ports and admin ports are not even reachable publicly. And so what happens, the general flow here is you have your redirector publicly exposed, and as requests from the internet come into your redirector, in this case, I'm using Apache mod rewrite as the redirector itself. And as web requests come in, then mod rewrite has conditions, what they call rewrite conditions, and it checks every request, the header values of those requests, and then it makes decisions based on the rewrite conditions. So in this case, as requests from the internet come into your redirector, if those requests match whatever conditions you set that your C2 payload has, so if your C2 payload has a unique user agent string or has a token or something unique to it, then it checks those requests, and if it finds those unique values, only then will the redirector allow the traffic to the backend C2 server, where it essentially will be a transparent proxy. But if the traffic does not meet those rewrite conditions, then a 404 not found is returned. So essentially, like scanners or if blue team's poking around or someone in general is poking around, they're going to get 404s for your server unless they're using the exact strings that your payload is using. So in this case, it's important that your payload have very unique, at least one unique header value, preferably more than one. And you, in this example, you put your domains on the redirector. So again, if domains are burned, you just spin up a new redirector, point it to the C2 server, you're back up and running, versus putting your domains on the C2 server. When it gets burned, you've got to rebuild everything all over again. So here's another view of what I mentioned before of how your backend C2 server, only Red Team operator IP space has SSH access, and only the redirector has access to whatever C2 ports you're using on the backend server. So again, Red Team operator IP space is able to SSH in to the redirector, but the redirector itself is publicly exposed when it comes to web ports. And it's by that way, it's basically that way by design, so that as requests come in, it can check the headers and filter either 404 if rewrite conditions are not met, or be a transparent proxy to the backend C2 server if like the conditions are met, or in other words, if it looks like the payload is the one making the request. So next, let's jump into some automation examples. Now that we've sort of talked conceptually about how a few different scenarios for Red Team Ops work, I will say there are different approaches and tools, so you do not have to use the tools or approaches that I'm mentioning here. These are just things that I've like, basically things that I have used and that I've found to be very useful personally, but it doesn't really matter as long as you pick something that works for you. And so I just wanted to call that out. So an approach that I like using shell scripts for the purpose of capturing configuration info from the operator. And then the shell script basically takes that data in the form of variables. It does variable replacements in your Terraform scripts, and then it actually launches Terraform. And of course, Terraform will then spin up your infrastructure in the cloud provider that basically whatever cloud provider you've configured. And so the nice thing about this approach is you can use this across various cloud providers like Linode, DigitalOcean, AWS, etc. Essentially, all it requires is that your cloud provider have an API, and that Terraform have a method of reaching that, like a library of reaching those APIs. And Terraform can pretty much talk to any cloud provider. So that's usually pretty flexible in that regard. So let's take a look, going back to the phishing server example. So again, I'm mentioning that in this example that DigitalOcean is used and GoFish is being used as the phishing server itself. So within DigitalOcean, first what you'll need to do is set up an API key in the admin panel, and you'll also need to load an SSH key. So essentially you'll generate an SSH key pair locally, and then you'll load the public key of that into your DigitalOcean admin panel. So those will be the two prereqs, and then the shell script, again, once run, will gather configuration information based on questions that it answers, and the operator provides answers to that. And shell script takes those answers, does variable replacements in Terraform files, runs Terraform, and then Terraform spins up the GoFish server for you. So let's look at an example of the shell script itself. So first section in red is ensuring that Terraform is installed, and if not, it will install it for you. In this case, it's just doing 2 checks. It's looking for either Linux or Mac OS, and if it's one of those 2 operating systems, it will ensure that Terraform is installed. I will note that for Mac OS, the Mac OS install, the only prereq there is that you have Homebrew installed on your Mac. Second section for configuration information. This is where I mentioned the operator puts values in to configure the infrastructure that you're standing up. So we can walk through the different configuration values here. One being the name of your droplet. So when you're in DigitalOcean, what name do you want your droplet to be called? Let's see, the name that you want to call your firewall role. So in this case, you're using the DigitalOcean Cloud Firewall. You could also use like a host-based firewall like UFW or IP tables, but in this example, we're going to use the DigitalOcean Cloud Firewall. So you're going to give a name to that of what you'll see in your DigitalOcean admin panel. The source IP that you log into your C2 infrastructure from. So in this case, since this is specifically for a phishing server, this will be for SSH access, and for the admin port access for GoFish, you're restricting those only to the red team operator IP space that's provided here. So it can be an IP or an IP range. Next, you'll enter your DigitalOcean API key, which will be used by Terraform in order to access DigitalOcean on your behalf. And then you'll enter the name of the DigitalOcean SSH key. So that's the key you've already loaded into your admin panel. And you also add the path to the private key that pairs with that public key. So again, it's gathering all the configuration information here. Then you're going to the next section, you're going to do variable replacements. So now that you've gathered this information, you're going to do variable replacements in the Terraform scripts. So things like you're going to take the droplet name and put that in there, the firewall name, the name of your public key, your admin IP or admin IP range, all that information. You're doing variable replacements now so that the configurations are specific to what you put in Terraform. Next section, you're actually running Terraform. So you're doing an init, a plan, and an apply. And once you hit yes, it will basically spawn off, and Terraform runs, basically is off to the races and is spinning up your infrastructure. And then at the end, you're doing an initialization where you're ensuring that the files, the template files, are back to the original template format, because again, we did variable replacements earlier. So we're just cleaning things up at the end so that you're ready for your next run. So now that we looked at the shell script for phishing, now let's look at the Terraform script for phishing. So at the top, you've just got your droplet information, such as what operating system and version, like in this case, Ubuntu 20, the name, my C2-1, that's a placeholder in my script where I just replace that with whatever the operator wants to name it, region, etc. Next section is setting up for your droplets. So what account that Terraform will use to log into your droplet. And next section is commands that we're going to run. So these are the remote exec provisioners, and these are inline commands that once the host is stood up, in this case, once our phishing server stood up, these are the commands that Terraform is going to run. It's going to do an apt-get update. It's going to pull curl docker. It's also going to pull docker compose down. It's going to set the executable flag for that. It's going to install git, and it's going to also install Golang. And after doing that, it's going to pull down GoFish, which is written in Go. and it's going to build it. So essentially, it does all that for you. And once the server's up, all the operator has to do is SSH in, CD to the directory, and then /gofish. So gofish is basically ready to be executed. Next section is the firewall config. And this is where I mentioned earlier, you're going to use the DigitalOcean cloud firewall as opposed to an on-host firewall, even though you totally could do that as well. And these are the rules that you're setting up in your Terraform script. And this also includes placeholders. So the 127.0.0.1, for example, that includes, or that will be replaced by the red team IP operator space. So in other words, only the IP or range provided by the admin will be able to have SSH access to this host. 80 and 443, again, publicly exposed because we expect that that's what we're using our trackers for. And then down at the bottom, there's another rule that you can't see, but that's the rule for the GoFish admin port. And that will also have a placeholder of 127.0.0.1, which is replaced by the red team operator IP or IP range. And so once this is run, the phishing server is stood up and it's protected behind firewall rules. Again, only the red team operator IP space can hit the admin ports, which is what you want. And you can SSH directly into the host and basically just do /gofish and it's up and running. Everything else has already been set up for you. So in this case, it's much quicker and it's very flexible. These are just screenshots here showing how the droplet was created, and the droplet was put behind a DigitalOcean firewall with all the rules we mentioned or kind of stepped through in the previous slide. So automation example, next one is going to be for redirectors. So again, just conceptually, we put redirectors in front of our C2 servers. We put domains themselves on the redirectors, not on our C2 servers, so that if they're burned, we just spin up a new redirector. And we only allow traffic from our implant to go to our backend C2 server. So you'll have to have some specific string, hopefully more than one string, that is very unique in the request header for your C2 payload. And that's what you use for your redirector to make a decision. And all other traffic will get the 404 not found. So in this example, we're going to use Apache mod rewrite. I personally like mod rewrite for redirectors because it gives you the option to be very specific in what you want to redirect. Other redirectors like SOCAT are also candidates for use, but typically SOCAT I use when I just want to redirect everything. So I like mod rewrite when I want to make specific decisions on what to redirect. And in this case, we're going to use the Linode provider, whereas we used DigitalOcean earlier, we're going to use Linode in this example. So the prereqs inside of Linode, first you're going to set up your personal access token, and then on your host, you're going to generate an SSH key pair. And essentially the personal access token and the SSH key pair, that's what's going to be used by Terraform in order to log in and start provisioning your host after it's stood up. So here's the example for an HTTP redirector. So essentially, in this case, your redirector is HTTP and your backend C2 server is HTTP. Later, we'll look at an example for SSL and kind of see what the differences are in your configurations. So first, I won't speak a lot about the top section because we already looked at that. It's installing Terraform if it's not there. Next section, you're getting configuration information again, but I'm going to focus on the bottom part that's specific to redirectors. So you're entering the domain name for your redirector. So as I mentioned, we're putting domains on the redirector. And usually what happens is for me personally, as soon as this spins up, because at this stage, we don't know what the IP address is going to be. So as soon as I run this, I kind of watch the provider. And as soon as an IP is assigned, I go and make sure I have DNS records set up for that IP address. And then in this example, you can enter a user agent string that will be very specific to your C2 payload. So something unique there. And then another example of a secondary item, you could add an authorization token like a bearer token into your payload as well. So then you'll have the user agent string and this bearer token that will be very unique to your C2 payload. which then makes for two high fidelity conditions where your redirector will look for both. And if the traffic making requests to the redirector don't have both of these, then 404 is going to be found. 404 is going to be returned, to the requester. So it gathers that information. And then the next section, you're doing variable replacements again. So you're replacing in your Terraform files. And this time we're also replacing in I'll say I have three unique files also that are being kept locally. So in this case, like Apache itself, I'm keeping the config files, like a version of the config files locally, and I'm editing them locally. And then when Terraform runs, it's going to move them over to the new instance. I personally found that to be one of the easier ways of trying to, on the fly, configure Apache servers with mod rewrite. So I just have a templated version of these three files. I do variable replacements in the files based on what I'm trying to stand up and the values of the operator. And then when Terraform runs, it moves them over to the new instance. So you'll see some examples of that in the next slide. Then of course, you run Terraform and initialize. So let's look at these examples of the Apache files. So the files that I use in this example here, you have 000default.conf, .htaccess, and then a local copy of apache2.conf. The reason, again, I kept all these are mainly the three key files that you'll need on the Apache server in order to have mod rewrite set up and running for you. So first, you have your 000default.conf, and here, of course, as I mentioned, there's going to be some placeholder values that your shell script's going to do replacements on. So for instance, the www.domain here, that's going to be replaced by the domain entered by the operator. Your rewrite engine is on, so that's enabling mod rewrite. You have two rewrite conditions here, one being the user agent. The user agent here is another placeholder that's going to be replaced by the user agent value that the operator entered. So whatever that unique user agent string is for your payload. The rewrite condition, the second rewrite condition here is the authorization string or the bearer token for your payload. And that start of auth string, that's a placeholder as well. That's shell script's going to replace that value with what the operator entered. And then your rewrite rule. So if those two conditions are met, send traffic here in this way. And essentially what it's doing is it's sending the traffic along with the URI to the backend C2 server. So that C2 IP here is a placeholder that's going to be replaced with the IP address of the C2 server provided by the operator, and the P along with the proxy pass reverse in the next line that allows mod rewrite to be a transparent proxy and essentially proxy the traffic to the backend C2 server. The rewrite rule at the bottom, if the conditions are not met, return a 404. So that's sort of stepping through to 000default.conf. .htaccess, very similar to the 000default.conf. It just has a little bit less, but you can still see the same logic for your mod rewrite with enabling it, the rewrite conditions, the rules, the proxy pass reverse, etc. And last item, the apache2.conf. I did not show the whole file here because obviously it's verbose, but honestly, the only thing I'm changing is just this tag here, this section of apache2.conf, your var www directory. So ensuring that allow override is set to all. And you take, so I had the full copy of apache2.conf locally, 000default.conf locally, and htaccess. The variable replacements are done, and you'll see in the next slide, once Terraform starts running, it uses a file provisioner to then move these files and put them on a server after we ensure that Apache's installed. So here's the Terraform script for, again, HTTP redirectors. So here's the file provisioner that I mentioned for each of the three files we looked at. So the source is where it is locally on your host, and then destination is where we're going to move it to on the new host that we just stood up. So in this case, the new redirector. So you can see that 000default.conf is being moved to the root directory. Actually, apache.2.conf and htaccess, they're all being moved to the root directory, and htaccess is being renamed to .htaccess, which is how it is on the Apache server. And then at the bottom, you have your remote exec provisioners. And these are the commands that are run in line. And the section in yellow, I'll just focus on these being specific to mod rewrite. So you're enabling mod rewrite and some of the modules that you'll need, and then you're performing a move of these files from the root directory to the proper directory that Apache expects these files to be in. So you're basically, you took the blank templated copies locally, you made the changes, you moved them to a temp directory for a short period of time while the host is being stood up. Then after it's stood up, you move it on over to the expected directory. So I found it to be a pretty nifty way of getting or managing Apache remotely without even having the server stood up yet using Terraform. Then of course at the bottom, you restart Apache. And once you do that, the server is actually up and running. And that's the part that I like about it, is just through running these scripts in a matter of a very short period of time, your redirector's up and the rewrite conditions are in place and it's already in front of your backend C2 server. I didn't show it here, but I also have scripts in place for the backend C2 server. And those scripts sort of walk you through a very similar process where this time it allows you to input the name of or host name or IP address of your redirector. And then it sets up firewall rules so that only the redirector can access whatever payload ports you're using. And it also prompts you for your red team operator IP space so that only the space you provided can SSH in. So I have scripts for that. You've got your mod rewrite scripts, and you run both of those and you're really, it's just, I personally enjoy it, just having the infrastructure stood up for you, where now as requests come into the mod rewrite server, the conditions and logic you specified are in place. And if it looks like your payload or those conditions check out, then the payload is transparently proxied. Everything else is given 404. So for SSL, it's pretty similar. We just have some new lines. So I'm going to speak to those. The new lines are in orange here in the files. So you can see things like SSL engine on, SSL proxy engine on. It's just turning on the SSL modules for mod rewrite. And we don't care about verifying the peer CN or checking the peer name, any of that stuff. We're just setting it up specifically for enabling the SSL modules and using SSL as a transparent proxy. And you see here, we also have the SSL certificate file and SSL certificate key file. So you can see here, it's using a Let's Encrypt directory path. So on a slide or two from now, I'll show you how the Terraform commands are taking care of Let's Encrypt for you for your redirector. It's standing up the domain that you provide. So it takes care of all that for you, which is pretty nice. And it still has some placeholders here like www.domain here for the certificate lines. Both of those get replaced by the domain that the operator enters when the shell script prompts it. Then of course at the bottom, like your HTTPS or the lines that were previous HTTP, you're changing it now to HTTPS since your backend C2 server is HTTPS. And of course, the same variable replacements we talked about before, like the user agent here, startup off string, C2 IP here, all that's going to get replaced by the values entered by the operator. For your 000 default.conf, same thing here. This is pretty much the same lines in orange that we discussed in htaccess. And apache2.conf, really nothing changes here. It's the same as before. We were just keeping a local copy because we're ensuring that allow override is set to all. So you have your 3 files here for SSL redirectors. And here's your Terraform script. I'm just going to focus on the yellow section specific for SSL mod rewrite. So again, you're enabling mod rewrite modules, the ones you'll need, such as the SSL module, the proxy module, etc. You're enabling mod rewrite, and then you're also installing, or you're setting up the software properties common repo and the universe, the apt repository universe. And then from that, you're installing certbot, and you're installing certbot or Python 3 certbot Apache. So once those are installed, this is the next line at the bottom, the last line in the yellow square. That's the line that takes care of your SSL, your Let's Encrypt SSL cert for your SSL redirector. So in this case, you're running certbot, and you have a couple placeholders, domain here and www.domain here. So those are placeholder values that get replaced. And it's registering unsafely without email, agreeing to terms of service, and no redirect. Those are put in there so that essentially this one line will take care of installing the cert for you on the new host without having to pause and wait for the operator to respond to prompts. It just does it in one command and essentially sets up your SSL cert for you. So things I like about this approach with on the SSL side is it takes the pain out of manual mod rewrite configurations. A lot of times what happens is for us on the red team side is we'll stand it up manually, have a lot of steps that we're using, and even some tricks that we've learned and won't document it. We'll step away for a month or two doing something different, come back and kind of waste time trying to think of what those shortcuts were that we used. Couldn't remember, some of the pitfalls or mistakes we made before, et cetera. So the nice thing here with automating it is you now have a clean flow of the steps to take, what worked, what didn't work. You've already worked that out, and it takes the pain out of doing it manually because now it's all run and taken care of via your shell script and Terraform. Again, it takes care of the SSL cert for the new redirector. So that part is really nice. You just provided a domain and it goes on from there. The redirectors are C2 agnostic. So it doesn't really matter if it's Cobalt Strike, if it's Empire, if it's Mythic, it really doesn't matter because essentially the redirectors are checking for header values from your payload. So it really doesn't matter. You can put it in front of any command and control, which is really nice. The thing I like personally, again, about mod rewrite is you get more granularity on how you want to filter. So you can have specific rewrite conditions on certain values. The examples I showed are just like scratching the surface. You can do other things based on other conditions, such as URI paths that you can filter on. And again, this approach makes your team more resilient so that when your domain gets burned, you're just losing a redirector. You stand up a new one, point it to your C2 server, you're all good to go. So it keeps your backend C2 infrastructure protected and not exposed, which is what you want from a security perspective for your red team infra. So just some lessons learned, just to reiterate here. I do think automation can be very helpful for red teams in general. It really helps, like we looked at that stacked plate early on, it helps weed through where you want to spend your time and what you can automate and have Terraform do some heavy lifting for you. I've been a part of one-person red teams, and I've often joked that the times where I've been a one-person red team, I've mentioned I'm actually a red team of two, myself and Terraform does most of the work. It's been my joke just because I really love leveraging Terraform and having it do as much of the heavy lifting as possible. Again, there's lots of different approaches and tools you can use for automation. I didn't even scratch or touch in on Ansible because you can use Ansible playbooks. There's all sorts of different approaches. You can even write your own scripts that interact with the APIs of cloud providers. So you're totally not restricted here. I just think that the main point is we should be using automation in some form. So however you choose to do that, it's up to you, but just make sure you're comfortable with whatever approach you use and that it's scalable, secure, and flexible. Again, I recommend automating as much infrastructure management as possible. And along the way, as you're automating, just make sure you have good documentation on your setup so that as you add new members to your team, or if you depart from the team one day, like there's a good trail of documentation so that everyone knows like how we manage red team, how we manage infrastructure on our red team. And that there's no downtime trying to figure out like, what do we have, and et cetera. I also think it's ideal if possible, like in these slides here, we talked about an external infrastructure environment. I use Linode and DigitalOcean as examples, but here, I think it's also important if possible to have an internal infrastructure environment as well that may be part of your organization's like managed service, but it's not like part of the general security groups, internal infrastructure, if you will. So in other words, like having infrastructure internal that you can leverage as part of unique exercises internally and kind of help validate sort of where the visibility gaps are. It may even be helpful for some exercises to have internal infrastructure that is visible and is part of the security's overall like internal infrastructure environment, just to test visibility there. So I think it's, long story short, I think it's good to have infrastructure in multiple environments, externally, but also internally, so that you can test visibility and detection at different layers and with different scenarios. So some references that support a lot of the data here. I have a blog on Red Team Infra Automation that has more details. I also included links here to my Linode and DigitalOcean Terraform scripts, and these scripts handle standing up phishing servers, EvilJinx 2 servers, and C2 servers. Also included a link to my mod rewrite automation scripts for DigitalOcean and Linode. Also helpful reading, I thought, would be Tim Malcolm-Better's blog on safe red team infrastructure, and Blue Screen of Jeff. He also has a good wiki on red team infrastructure. So definitely recommend checking those out as well. So thank you all for having me, and feel free to reach out if you all have any questions. Thanks.